Hey guys, welcome back to the Prehistoric Life podcast. I'm your host, Eric Crawford, and today we have a special guest. Would you like to introduce yourself?
Sure. My name is Noel Ouellette, aka Paleo Noel on Instagram. So I'm a fossil hunter, I'm a science communicator, I'm a paleoartist, and I'm living in New Hampshire. And despite, New Hampshire being the granite state, it's not really the best for fossils. I've followed my passion all across the country and have been able to make some pretty great experiences along the way. So let's talk about some paleo.
So the basic question that I start off every interview with is, what is your favorite dinosaur?
Since second grade, my favorite dinosaur has been Giganotosaurus. And that was, at least initially, because it was something different from T-Rex that was comparable in size and, an equally impressive predator. But something, while looking vaguely similar, or at least superficially similar, it's totally different in its evolutionary history and what it's adapted for. So I thought that was a really cool creature. And, back then when I was in second grade, it was a bit, closer, or at least more contentious as to if it was bigger than T-Rex or not. A little recently, it's been sort of outmassed by a couple tons.
Yeah, we got it.
But who knows? Maybe more material will pop up.
Just got to keep digging for it.
Sample size,
All right. So could you maybe dive into a little bit of what you do?
Sure. So I've been fossil hunting since I was 10 years old. And then at around 15 or 14 or so, I began using my fossil collection as a tool for science communication. And my first opportunity to do so was at the Sea Science Center over in Manchester, New Hampshire. And I would bring my fossils over and some of my drawings as well, and show them, interact with the kids and some of their parents and grandparents, and have the opportunity to talk about fossils. And then since then, I've given different talks, and not really lectures. I try to be more engaging than just a lecture, but try to be hands-on. I have opportunities for people to touch the ancient past, and I think that's a really great thing. I've been able to do that at libraries and classrooms, and then more recently, so I met your buddy Dan Mossy, and we hosted a panel at a local brewery, and that was hosted by the Sea Science Center. That was pretty cool. That was my first time doing something like that. That was Science on Tap, and that was really a really great experience. But more recently, I joined the staff at the Seacoast Science Center, and I'm one of their seasonal naturalists. I joined in the fall. It sort of winded down for the winter, but I'm going to be picking back up with that in the springtime. Yeah. Then I also went to Allegheny College in Western Pennsylvania. I graduated in 24, but I studied geology and then did a studio art minor. So that was a really great experience. My advisor while I was there was shark expert and biomechanics expert, Dr. Lisa Whitenack. So shout out to her. And I also, while I was there, worked on a Paleo in the Parks fellowship, looking at seacoast, or not seacoast, but shoreline and seacoast fossil resources. And I was able to present that research at GSA, that poster. That was a great experience.
Yeah, we're on a bad slope with the East Coast here. We don't get much. We get some things, not much. When it comes to dinosaurs, at least. We get a lot.
Where are you at?
South Carolina.
Oh, okay. Yeah. Get a little bit of dinosaurs up there, but not a ton.
So how do you tailor your presentation style when moving from like formal school classrooms to like a casual setting, like you talked about, like a local bar?
Yeah. So the local bar was like one where we would just be sitting at this table, and we have some fossils and some casts, some artwork on display, but we're there. We have the microphone. Dan and I are just taking questions, and someone's taking the questions from the people on the tables. But for something like a classroom, I did it where I had my fossils laid out on a table, and then, well, I've done it before where I have like a presentation slides and talk a little bit about myself, but then we get closer into the nitty gritty and allow people to, really interact with the fossils. Like, a kid gets the opportunity to hold a megalodon tooth for the first time, or, a piece of Triceratops frill. And I think that's a really great opportunity for them to get hands-on experience with fossils, and ideally to be, inspired by that direct contact with them.
It's kind of nothing like seeing someone like witnessing a fossil for the first time. It like activates something in your brain, and you're just like, that's what I've been striving for. Like that.
Absolutely.
What are the unique challenges of communicating complex topics like faunal turnover to a general audience?
Well, I would say that it's not the most difficult. Well, it can be difficult explaining ecological and paleontological concepts to people, but I think it's relatively easy to get across that environments change over time, and there are specific environments that have specific groups of animals represented, and then in a number of thousands to millions of years, that environment changes and the fauna changes over time. So it's not. I think people can get that through their mind most of the time if they have a some sort of conception of geologic time as it passes, but not everybody does.
It does make it a little more complex when you have to back up and talk about the geology part of it that turns into the paleo side and the bio side. It does add that little extra lesson, I guess.
And then I think it's important for them to realize that it's an interdisciplinary science.
Get a little bit of everything.
Heavily interwoven.
Physics, engineering, bio, of course. You got the actual geo side, excavating. I mean, you get a little bit of everything. How does your work as an what just popped up here? Hang on a second. Sorry, there had some technical difficulties. Let's just dive right back into this. How does your work as an avocational paleontologist in New Hampshire influence the specific prehistoric stories you choose to tell?
That's a good question, because New Hampshire, being the granite state, it has very little fossils. And as a result, I have to pull from the geologic and paleontological histories from local states, especially. So I'm talking about dinosaurs. I have to bring up the Connecticut River Valley and the Newark supergroup, where it's essentially a rift valley system as Pangea is pulling itself apart from the late Triassic to early Jurassic, and that in those rift valleys you get lake beds, and in those lake beds you get dinosaurs running around and leaving their footprints. So that's the simple way of explaining that. That's why we have a small record of dinosaur tracks from, and mostly in Connecticut and Massachusetts being the closest states to New Hampshire that have those. And then also explain the rare existence of some dinosaurs like Podokesaurus and Ankylosaurus from those states. And then also I'll sometimes touch on like the fossils that can be found in New Jersey, so the first time I went to hunt for shark teeth was in eastern New Jersey. It was the late Cretaceous stuff. So you find like Squalocorax and goblin shark teeth as well. And in those similarly aged sediments in Jersey, you get some of the earliest dinosaurs that were ever discovered in the United States, like Hadrosaurus and Dryptosaurus. And New Hampshire doesn't really have any of that. But when you think about modern ecosystems or modern predators and giant herbivores, they tend to be able to move pretty effectively across their environments. So you would expect something like Dryptosaurus to have ranged into an area like New Hampshire. It wouldn't. Dinosaur provincialism is an interesting topic, but because of the lack of the fossil record in Appalachia, it's really limited. So you can't make many inferences about it. Not exactly like Laramidia in the western half of the United States and Canada.
I think our main problem with the East Coast here is, well, obviously the Appalachian Mountain Range. Forming that kind of gets rid of a lot of that fossil record that would have been there. I am fully confident that the prehistoric during the Mesozoic on at least our coast would have been flourishing but
Yeah.
sadly, the Appalachian Mountain Range forming gets rid of a lot of that fossil evidence. But we can't make any actual predictions on very specifics. Like we have like Appalachiosaurus. So it's like, okay, we have a Tyrannosaurid. We
Yeah.
have this Hadrosaur and this Ceratopsian. So we clearly had some kind of Cretaceous relation to the West Coast.
Yeah.
But outside of that, we don't get a lot. So we don't get a lot of nitty gritty.
Just get scraps. Yeah.
Exactly. And we fall into the like evidence of, or like, what is it, like absence of evidence is not evidence of absence.
Yeah, exactly.
I mean, we really don't know what the ecosystem was, what like the fauna of the ecosystem during, especially Cretaceous, was like here, because
yeah, I mean, we have
nothing.
So we have, much, and even then, so we have a very limited amount of evidence, even from the Cretaceous, and that's significantly better compared to the non-existent Jurassic, or at least late Jurassic. So well, we can touch more on the Cretaceous stuff, but there's literally like, I don't think any late Jurassic formations on the eastern seaboard. There are the early Jurassic stuff in the Newark supergroup, but when you see the Morrison Formation and then the Lourinhã Formation in Portugal, Morrison being in the Western Basin area, but they share nearly identical faunas, and even the same genera, like Allosaurus, being on both sides. So one would expect that Allosaurus passed through eastern North America at some point in its time, but we have no evidence for that, unfortunately. But based on those fossils being there, you have to infer, and it's kind of tough. One of these days, hopefully we'll find like a little pocket somewhere nestled away. Maybe it'll be like in Canada somewhere, and just somewhere no one has expected at all.
I could see Maine.
I don't know about Maine, man. So part of the reason, at least in the northern part of the eastern side of the continent, that's where all the glaciers were, and they've just scraped away and destroyed everything from, well, most of the surface soils. They get a lot of, so in New Hampshire, you have granite, which is an intrusive igneous rock forming in the interior of the world and from cooling magma, but the glaciers scraped away everything on the surface of that and just left those boulders, and they did a number on all the formations. You do wonder what would have been up in New Hampshire at that time, but I have no idea. It's hard to picture.
Like it's especially since especially with the way the world was moving, like how much of our coast was underwater during that time, if there was any underwater. Okay, cool. I guess we could search for stuff in Scotland.
Yeah, there is stuff in Scotland. So that's probably, or it's closer to our best bet, at least in terms of like connection there, because the North Atlantic starts to form in the Triassic Jurassic boundary, but you still have that connection there with Northern Europe. And I don't know how long the Arctic type of corridor existed, but it occurred intermittently as well. And there's evidence for different faunal exchanges happening at different points in Earth's history, and Scotland was certainly it could have been a gateway. You have the fossils, the footprints in the Isle of Skye, and that's the Middle Jurassic. So you have something of an idea of what's going on, what could have been going on in the northern part of the United States and Canada at that point in time.
Yeah, especially a lot
closer.
I mean, for those of you who probably don't know, the hills of Scotland are actually part of the Appalachian Mountain Range. Those formed as one part. Scotland breaks away, becomes, well, Scotland. So, I mean, at least during that period, and then I guess not everything after, but everything before or partially before, you could kind of make somewhat of an argument for existing same place because it was one mountain range.
Yeah.
Very interesting.
In the Carboniferous and Permian, especially, you get like that continuous, those coal forests occurring along. I think it's around this, or were the Appalachians the Central Pangean Range? Am I right in that thinking? Where with everything pushed together, that's basically the center of the continent. So I think that's what accounts for what we think of it as. But you would have had a continuous, or a pretty continuous fauna with stuff like Arthropleura and some of the other, typical for a species like the lepidodendron tree or tree. You know, it's not related to any living tree, but they're
And
arboraceous is the
it
term.
looks like
It resembles a tree, but I don't know. I'm not a paleobotanist, but I do have some interest in it, like a light amount.
if it looks like a tree and acts like a tree, it's a
Yeah, you
tree.
can call it a tree. I mean, if grasses and oak trees are more closely related to each other than they are to pine trees, then I think you can call whatever resembles a tree a tree. I don't know.
It taxonomy is a whole nother rabbit hole.
Yeah, it is.
That's a never-ending battle for me at least.
Constantly.
What specific evidence for dinosaur diets do you find most compelling to illustrate in your art?
Yeah, so in my senior year, I did a project for one of my seminar classes, and that was my goal was to make it a book and publish it eventually. I have to do another draft of it, but the project was what did dinosaurs eat for dinner? And that was based on or representing different fossil species or dinosaur species with their prehistoric diets, specifically what we have evidence for. So, we have inferences based on teeth and what we expect dinosaurs to be eating. But we have a lot of different examples where we have direct evidence for it, where we have shed teeth at carcasses, we have gut contents, we have coprolites and cololites, and then regurgitolites as well. And I think that's super compelling to learn about, where you have direct evidence for these ecosystem dynamics where you have different trophic levels represented. You don't have like the fossil turduckens, at least not in the dinosaurs yet. Have you heard of those where you have 3 levels of the ecosystem represented? Like I was reading, so I have Locked in Time by Dean Lomax, and he talks about that. And there's the one example from the Messel pit where you have the snake with the lizard with the beetle inside of it.
Yes,
Yeah, and then there's a Permian example where you have a xenocanth shark, and then you have a temnospondyl with a little fish inside the temnospondyl.
I would imagine those are incredibly rare and happen
Yeah,
once in a life.
you need to have them in a Lagerstadt deposit. So a place like Yijian Formation in Liaoning, China, would be a good place where it could happen. But places like those are sort of critical for that understanding where they're preserved really well, because so Microraptor is a really good example where you have a wide variety, or you have a sample size that's wide enough, and then you also have really great preservation in those where you can see their gut contents, and that proves that they had a very generalist diet. There's been mammals found in them, birds, fish, lizards, so a little bit of everything. And then let me see, actually, I have my art. I have it right here. I'll show you. Painting I did. So I did watercolor on top of a sketch, and that Velociraptor, Deinonychus in the middle, and then Microraptor on the side. And you have a Deinonychus over a Tenontosaurus leg. I did the positioning based on the Mark Whitten pounce on the thing. But yeah, so Velociraptor with a little Protoceratops head on the table, a pterosaur wing because they found Velociraptor teeth and bits and fragments of pterosaur bones, and I think the Jadokta in Mongolia. And then a little closer, you got a lizard, mammal foot, little bird, and then some fishies here for Microraptor. But that was a really fun exploration to do, where you investigate from, or I investigated from, like the earliest dinosaurs and stuff, looking at stuff like Coelophysis, where you have the regurgitolites, and the gut contents, where they have the early Pseudosuchi and like I think Hesperosuchus or something similar to it. And then you have to with Coelophysis, you got to mention the potential for cannibalism, whether or not you find the evidence compelling for it. There's the original case where they made that, they think it wasn't representing that, where it was just like underneath or got washed in. But I think there's a separate example where it might be representing actual cannibalism, and I wouldn't put it past Coelophysis. But
those little things are scrappy and vile.
They're nasty. Yeah, they would.
I would expect nothing more.
Mm-hmm. But yeah, from the Triassic to the end of the Cretaceous, you have direct evidence from different dinosaurs leaving leaving traces of their diets on each other and in their environments. T-Rex is a great example of that, especially when you have like bone crushing jaws. You're going to pulverize and destroy a lot of stuff,
Yeah.
but you're going to leave marks on the bones. So there's tons of evidence for that in the Owl Creek, where you have, Edmontosaurus and Triceratops and other T-Rex being impacted by other, representatives of the tyrant king, and it really did rule over, its entire ecosystem. Let me grab that painting real quick. I'll show you that one. I did T-Rex. So I have T-Rex on what's your left. So right here, T-Rex missing the lower part of its arm. Got Tarbosaurus in the middle. Then I got Daspletosaurus right here. And then a little Daspletosaurus lingering on, being dragged by biting the, nail biting of that hadrosaur leg I got. So
Look at that.
yeah. So
And I mean,
yeah. So there's evidence of like the feeding on the gastralia of Dinosaurs. So I did that little basket of belly ribs there. There's I think associated with the Daspletosaur bone bed in the two medicine, so D. horneri. But in the two medicine formation, you have evidence of like, I think there's some evidence attributed to Daspletosaurus and feeding on hadrosaurs, and there's some maybe digested material, but then you get hadrosaur tail here, some little horns to use as toothpicks for Triceratops, little bits of frill because you get evidence of bite marks on those, and a big old drumstick, which you could attribute to whatever you want, but both T-Rex and Tarbosaurus in their own environments were feeding on everything, including stuff the size of Titanosaurs. So that's sort of what that's meant to represent.
Tyrannosaurs were probably carnivores in general, were just carnivorous generalists.
Yeah. Anything that they could get in their mouths.
That was, if I'm not mistaken, that's the same with Allosaurus, and I want to say Torvosaurus partially.
I don't know if we have enough evidence, but like I would expect it to be the case, but Allosaurus for sure.
Allosaurus
being the more common one.
70% of the Morrison fauna
exactly
sauropods is actually a scary statistic for those things.
Yeah.
And I mean, speaking of which, I don't know if you've seen the Dr. Brian Curtis and Oswald paper about Ceratosaurus saber, their hypothesis.
Yeah, I've heard of, or I just heard about that being published. So tell me what you know about that. I'm interested to yeah.
I guess at the time of this episode coming out, it will be next week. No, week after time. So I should already have an episode about that out by now.
Yeah.
From my understanding, it is the hypothesis that those kind of, I don't have a
elongated teeth. Yeah.
Face. I'll use this Saurophagnax, but the teeth kind of in this general area for Ceratosaurus. This is not a Ceratosaurus.
Yeah.
Again, for all of you people, are kind of elongated to kind of get that swifter neck bite to swiftly kill so that it can get food from before being bullied away by Torvosaurus or Allosaurus in the environment.
Yeah, that might be a pretty effective way. So one of the things, so speaking of Brian Curtis, he had posted on his Instagram or Facebook, but it caught my eye, and I don't know if it's been published. I did ask. I don't think he had, but it was on Big Al too, and there are gut contents there where it includes stuff like, I think, a Dryosaurus or another small ornithopod leg bone, but a lungfish tooth in that gut content. So a real generalist there. That's pretty interesting to me, because you don't see adaptations in Allosaurus for feeding on fish, but at the same time, you eat whatever you can. If you're in the Morrison, you find a lungfish, or you're digging around a riverbed to try to get water for yourself, and you happen upon a lungfish, you're not going to pass it up because it's all slimy, just going to go right down the gullet.
Huge, robust, not as big as T-Rex, but those huge, robust steak knife teeth.
Yeah.
So they just ate anything, it seems like. With the amount of them, I would actually be interested to see if there is any study for like cannibalism within them.
I think there is. I remember, so I think the study was accompanied by work by Brian Eng, who's one of my favorite paleo artists. But if I remember correctly, there's different bite marks and then maybe shed teeth in some Allosaurus sites. I think maybe Cleveland Lloyd. I'm not exactly sure, but I remember that particular artwork where there's like an Allosaurus carcass and there's Allosaurus and Ceratosaurus fighting over it and ripping each other apart in a
I
gruesome and grim way. But that's like part of my favorite parts about Brian Eng's artwork.
Within Allosaurus, I really wouldn't be. I don't know about Ceratosaurus or Torvosaurus. I don't know how much we have on those
Not
diet
very much.
wise, but I'm not surprised by Allosaurus being a cannibal.
Yeah.
Speaking of artwork, I mean, how do you visually represent the concept of paleobiogeography to help people understand how ancient continents were connected?
So it's not as much me. Well, I'll talk about, whenever I talk about paleo, I'll talk about a whole variety of concepts. But because I have an interest in, the global science of paleontology, I like to talk about fossils that have been discovered all over the world. And in doing so, it's important to understand how the continents have shifted and then different ecosystem patterns. So like the different clades that move in and out through different continents over time. It ties very closely with the faunal turnover type of stuff, where, for example, you have like the Carcharodontosaurs and Titanosaurs being dominant fauna across both the northern and southern hemisphere throughout the end of the Jurassic through the Cretaceous period. And then you have a major cutoff in the middle there where you have that sort of sauropod gap in North America until Alamosaurus and its relatives come in. But then you have the entire annihilation of the Carcharodontosaurs. So my favorite guys, or at least some of them, go extinct in the middle of the Cretaceous there. And then you get their replacements as the dominant predators in the ecosystems. You get the Tyrannosaurs in the north, and then you get the Megaraptorans and Abelisaurs taking over as dominant predators in the south. But there's just fossils to be found all over the globe, and dinosaurs in particular, and even in places you don't expect, like the high Arctic or the Antarctic. And there's those unique faunal groups, but there's also related animals to what we're more familiar with at lower latitudes, or famous dinosaurs we're familiar with in the United States and elsewhere. I like learning about the Antarctic fauna. I think
Yeah, those are very interesting.
yeah, super interesting. And I hope we find more, or, one day that's my goal. Or like, I would really love to be a part of an expedition to go find Antarctic dinosaurs and try to expand that knowledge, because every piece really does make an impact and add to that picture that much more.
You actually mentioned Megaraptors there, and that's actually something very interesting to me because they're both in Australia and Japan, with Fukuraptor being one of, if not the oldest Megaraptor, if I'm not mistaken.
It seems like the oldest ones in that group are from Asia. So
Asia.
and there's also the Thai like Vayu-raptor.
Yes.
Yeah.
So
but those, yeah.
It kind of seems like they migrated from kind of that Asia down into Australia somehow. Then they just kind of appear in South America. So, I mean, they clearly crossed through Antarctica somehow, because it's not just convergent evolution. Like, they got over there. So
No, they're legit. So you have legit megaraptorids in both South America and Australia. And then you have the slightly more primitive stuff in Asia. And I really would be interested to know what exists in Africa. So our picture of Africa is, quickly developing or readily, continuously, building, but we don't have a great understanding of stuff like dromaeosaurs or megaraptorans in Africa. They were certainly there, but I would be interested to see within the next 5 to 10 years if anything comes up from there, because I'm not totally sure if there would be any connection between Australia and Asia in the early Cretaceous there to allow for that. migration, and it might have been. So I think it was the paper where they looked at the evolutionary patterns of the megaraptorans and then the tyrannosaurs. I don't know if you're familiar with that one from last year at some point, but they were suggesting like they develop in Asia, or like the earliest ones are around in Asia, and then which seems to be sort of like a evolutionary center point for tyrannosauroid evolution. And if you consider megaraptorans, either tyrannosauroids or a closely related group of coelurosaurs, then it sort of makes sense that they would be there in the first place. But they move through Asia, and then as that's still connected through Africa and Europe, they travel down through there, and then there's that direct connection to South America that way, and then that way they get through into Antarctica and to Australia. Who really knows? Like, I think that's probably pretty compelling, but we need evidence in Africa.
I would genuinely like to see if there is anything in Antarctica too. That would be.
I think there is. So I was looking at, I think the formation. I'm forgetting the name of the formation, but it was where they found a lot of the bird material. I don't think it was the Snow Hill Island. I think it was like Lopez de Bertadano formation. I can't remember exactly now, but where Vegavis was from, I believe, and I think they found scraps that they have attributed to megaraptorans. I'm not sure what exactly it has been, or what material there's been. I know there's been like hadrosaur stuff found there, and then other small ornithopod material, but a lot of it's sort of similar to Appalachia in that most of the material from terrestrial dinosaurs is bloat and float stuff from the coastlines.
Yeah. You gotta
most of the marine
take it with a pinch of salt.
Yeah, exactly.
Well, actually, you need a pinch of salt to find it. So, working on literal prayers down there. I mean, like, I'm genuine. I would love to have been in the I'm blanking on the guy's name. The one guy that was like, let's just go dig down here and see what we find. It's like, it's ice. What do you? Oh, you actually found stuff. Okay. Keep doing that. Keep doing that.
Yeah.
I would have loved to have been in whatever meeting room that guy was in.
Yeah, people will just look at him sideways like, what are you talking about? Why would we look for dinosaurs in Antarctica?
I'm sorry. You want us to go to one of the coldest places on Earth, covered in ice and snow, by the way, and dig?
Yeah.
All right, man. All right. How much you paying?
But that's the thing. Like in the areas where it's just rock exposed, you have no plants and ground cover to, impede you in your search.
Oddly enough, I think it's one of the hardest, yet somehow within that regard, easiest places to dig. I really wouldn't. Never been.
Yeah.
The trade-off is the ground's frozen.
Yeah, exactly.
You got to melt everything, then dig. But you also can't melt it because that damages fossils too.
Yeah, exactly. It's a balancing act. I don't know. I'd be interested to see the specific, fossil recovery methods that they incorporate into finding fossils in Antarctica.
I'm no expert in that, but I feel like it would be similar to whatever they're doing in Prince Creek in Alaska.
Yeah, you'd imagine. That's a pretty cool formation too. That gets, honestly, like for as remote and interesting and novel as fossils in Alaska are, I feel like Prince Creek has been getting a lot of attention in the last decade and a half. It's been represented in a ton of different paleo media, which is cool. I like that.
Especially with Nanucosaurus from there.
Yeah.
Get your own Tyrannosaur. You become real famous real fast.
Definitely. Even if it's scraps. But yeah, it's cool.
I mean, it's a really interesting. I mean, I got to go to Alaska 2 years. I don't remember.
Yeah.
Time has just been a thing. It's just been 1 year for me at this point.
It feels like that. Yeah.
A while back, I didn't get to go to Prince Creek because I did go with family, and they're like,
where did you go?
Anchorage, kind of the southern. Yeah. We went to a Seaward, Anchorage, just a bunch of those southern towns during the summer, of course.
Yeah.
And yeah, I was very surprised that there were like 2 naturalists. I was like, Man, like I would love to find a natural history. Oh wow, there's like 2 natural history museums here. That's actually crazy. I would never have. And then so you start looking into all this stuff, and it's like, huh? You get like all of the late Cretaceous stuff. You
They
get like
really do. They get a really good record. It's because of how like the island accretion happened there. They get, you know, well, honestly, it's a huge state on it. It ranges from a huge amount of time, so it makes sense that way. It's sort of like how you get a ton of stuff in like Texas, but a completely different or geologic history and trajectory. But just based on the geographic size alone, you get, a little bit of everything. And there's also, so it's not just the Prince Creek on the north slope of
oh,
Alaska,
yeah,
but
no,
you have
absolutely.
the Cantwell Formation, which is similarly aged. It's what you get in Denali, and then I think it's
They
St.
found it.
Elias, or I'm forgetting the name of the national park, but there are lots. It's a really great track horizon. So you get these coastal or like tidal flat environments where you're getting the footprints mostly of hadrosaurs, as you may imagine, but you're getting stuff like ceratopsians and tyrannosaurs and probably ornithomimids as well. But yeah, that's a pretty cool area, and it'd be interesting to see. I don't know, because a lot of the track horizons, especially like the East Coast as well, but they don't tend to preserve the bones quite as well. That tends to be like the river sediments more so. But it would be cool to see if there's the same fauna or if it's slightly different in southern Alaska, because that's a huge amount of space
Oh yeah.
between the two
I mean,
areas.
I guess if you go down far enough, I don't actually. Kind of if you get down to like this area over here in Alaska,
Mhm. Yeah.
you kind of get towards that like Alberta region. I would feel
Yeah, you get
outskirts of that.
Yeah, you get Yukon, and then it's not so far from British Columbia by the time you're in the
Yeah.
southern reaches there. So yeah, I think we have Pachyrhinosaurus, which ranges from
Of course.
Alberta all the way through Alaska, and therefore you'd expect, because it's in the north slope of Alaska, you'd expect it to be in southern Alaska as well. But and then you probably have an Edmontosaurus or an Edmontosaurin of some kind of similar creature. But so that brings me to my next thought I just had, or you reminded me of a thought I had. So there are similarly aged late Cretaceous beds in like Siberia and far eastern Russia in the Arctic Circle there. And I think I've seen like some sort of image of like just a sample of the teeth you find there. So there's like nodosaur and ceratopsian and dromaeosaur and tyrannosaur stuff. And it makes you wonder, is that either that doesn't necessarily need to be identical, because it may not be continuous with the stuff in Alaska, but is it very, very similar to what you're finding in Alaska? So are you finding, so for a long time, it's been just Sinoceratops we know about from Asia, where that's down in China, but you'd expect more than one genus of ceratopsids to be
Yeah.
in um, Asia at that point. And I would expect a Pachyrhinosaurus-like creature to be in that region there. And that'd be cool to find, just a completely, well, not completely different, but a similar but slightly different relative of that in far eastern Russia.
Well,
It
you
might
get
exist. This is a speculative evolution or speculative paleo, but it would make
those
sense if that type of creature existed.
Plasmosaurs and Centrosaurs. I mean, what about the other type of
It
ceratopsian?
makes you wonder where the Chasmosaurians are in the Prince Creek,
Yeah.
and yeah,
Well,
and
I
then
mean,
yeah,
I think Centrosaurs are more that northern area. Chasmosaurs tend to be on the southern part. Does it give you?
definitely the more derived Centrosaurs, as far as I'm aware. I don't know. I think it's really difficult to be placed, or like to make
It's
any concrete statements about that. But like, it seems like the Centrosaurs, the more derived ones like Centrosaurus and Styracosaurus, and then the Pachyrhinosaurus lineage, are definitely more northern based. But
very much
you
so.
also, by in the southern area, so you have the Nasutoceratopsines, which are Centrosaurians in their own right, despite having brow horns and stuff. But that range into the south there. But it seems like the more derived forms that we're either more familiar with, or at least more recognizable to most people, are up in Alberta and centralized in Alberta, I guess I'd say. But
And you mentioned Denali earlier, and that actually got me thinking about like pterosaurs. They found pterosaur foot footprints. I don't know why I'm
Yeah.
blanking on the word.
Mhm.
They're in Denali, so I'm curious about like. I feel like pterosaurs are a lot harder to place geologically, depending because like especially like something as large as like Quetzalcoatlus, where it's like yeah, it can just like fly around the globe.
Yeah, that's the thing they say, or like when it was first discovered and in the decades following it, before there was like really intensive study on Asdarchids and stuff, people were saying that, this thing is so big and its wingspan, it would allow it to fly around the globe. And you would expect that using modern birds as a reference, like an albatross. But it seems like the ranges, maybe it's just the geologic bias where there's not an extensive amount. Well, the pterosaurs aren't preserved really well in the first place.
Yeah,
And the
no.
giant ones, they make the trade-off for being, you get bigger and bigger and bigger, but as a result, to be able to continue to fly, you get more and more um, pneumatized in your skeleton, and you got to have dense bones to be able to support yourself, or like denser bones so they'll survive a little bit better. It's a whole trade-off there, but it seems like the only true Quetzalcoatlus remains we have are from the Javelina area in Texas, or West Texas around Big Bend, but the Javelina Formation there, and stuff that's been attributed to them has been identified as being slightly different, or at least unique comparatively. Like um Inferna Dracon, you heard about that one being discovered based on the
Yes.
single cervical vert from the Hell Creek, where Jane was found actually, which is pretty interesting. But that was for a while, I think. I'm not sure if it was that one in particular, but people always like to point at Hell Creek having Quetzalcoatlus, or at least something like it, but it isn't Quetzalcoatlus, it's something different entirely. I think it ended up being on the phylogenetic tree, if I remember correctly, it ended up being closer to Aramborgiania. So like the really even skinnier necked ones than Quetzalcoatlus. But there's all these different little lineages of these Asdarchids popping up and diversifying throughout the Cretaceous, and they have a huge global spread. It's really quite amazing. Every continent, I think, has them. I think there have been
Yeah.
scraps found in Antarctica as well.
That wouldn't surprise. That's even more impressive that that's survived there.
Yeah.
I mean, because especially with all the, I know like Australia has its own fossilization problems with everything. Like just all of the ground doesn't like to fossilize. It's just how it is in Australia.
I don't remember exactly how it worked, but I remember like the discussion of like how the soil horizons work there, where it's like really deep for some reason, and that like draws them up, but breaks them up into chunks over time. Yeah, it's
It's
tough.
it's just not good for fossilization. So what you find is like, we got something here. We can tell it's something. It's just
Yeah,
where it's like,
but every once in a while, so I mean, like that's probably the case the majority of the time, but every once in a while you get some pretty amazing stuff. So
oh yeah,
you have the Kunbarasaurus holotype. That was one that I drew in my um, paintings there for my what dinosaurs eat, because it had gut contents as well. It had little seeds and other bits and pieces of plant matter there. And then one that was published more recently that I will include in my final version of that work was the Dimantinosaurus specimen. It had skin preserved on it, and then had its gut contents as well, which is really fascinating because I don't know if that's ever been recorded or documented. I mean, I looked around, other than like coprolites, which are attributed to the sauropods. I don't know if there's been any gut contents specifically described to sauropod material, or at least reliably. I think maybe there's some stuff that like has been thought about being in like an apatosaurus. I remember like an old dinosaur book, and I think I did a little reading, but it was like a fish scale or a fish bone that was found in like the rib cavity of like an apatosaurus or diplodocus or something like that. But that was relatively unreliable as a actual indicator of their diet, I think. But
I'm curious how that would have gotten in there.
oh, the thing dies and it's being scavenged and its guts are ripped apart by an Allosaurus, and then ends up in the river. It's being covered by sand and bits and pieces and everything. And then fish has died and it's being washed into there.
True, true,
Yeah.
true.
And
Yeah.
that's part of the thing. So So when I touched on, let me pause. Let me go get the hadrosaurs. I'll show you that one.
Yeah.
So I did Admonosaurus and Corythosaurus, and I did Admonosaurus with a little speculative fleshy crest like they had in the specimen from, I think, Horseshoe Canyon, but and then Corythosaurus there. But both of those, there have been and then I based the foot on Dakota, the lovely Admonosaurus mummy from North Dakota. And then there's also another mummy of Corythosaurus. And I think both of these specimens had, or maybe another Admonosaurus specimen from like the mummy zone, or like the, I think it may be AMNH specimen, but both of these had gut contents preserved, or at least masses of plant material and other debris in the gut area. But there's, you caution exact correlation or exact association, because sometimes like the gastralia are missing, or the stomach is opened up,
Yeah.
and stuff can get washed in there. But it falls into what you'd expect for the diets of those dinosaurs, where you have like woody bits and pieces, and then pine needles and other, some traces of flowering plants. But then there's also, right here, I decided to incorporate the piece. So there's in the Kuiperowitz Formation in Utah, there's a coprolite attributed to hadrosaur or some sort of other large herbivorous dinosaur that has little pieces of crustacean in it, which was indicating that they are not entirely herbivorous, but could occasionally supplement their diet with stuff like crustaceans and crab, which is pretty interesting. I don't know if you ever heard about that one, but
I think it's kind of like it's one clip that's forever burned into my brain for some reason. It's like a clip of a deer eating a snake.
yeah.
I think it's something like that.
Yeah, there's like videos of the cow like munching on the snake in Australia, and then there's also one where like a female elk was following around like a goose with her goslings, and then grabs one and eats one. And there's a classic one of a horse in a barnyard where it like bends down to sniff one of these chicks, and then with its big lips just swallows it up. And it really, it's counterintuitive to what we expect with herbivorous mammals, but they do it all the time, and dinosaurs would have been no different. I actually saw, so it was the other day, and I'm familiar with the crustaceans one, where there's little bits and fragments of crustacean shell and the potential hadrosaur coprolite. But I just saw someone mention on Facebook that there's even like a lizard jaw section in one of these herbivorous dinosaur coprolites, which is really crazy to me. I didn't even hear about that, but that's wild.
So deer, typically herbivorous, may eat snakes to obtain essential nutrients like calcium, phosphorus, and salt. Especially during spring when they are pregnant or during times of food scarcity.
Yeah.
Wouldn't put that past larger herbivores. I mean, they're not turning carnivorous. They're just need a little something extra. So,
Yeah, whether they're eating like small critters or like nibbling on bones and stuff. Yeah.
I don't know how accurate the walking with dinosaur big old, I think it's Laura Titan, just straight up eating like a rib bone.
Yeah.
Another dead sauropod or whatever it was. Like I don't know how
I wonder if it was the pliosaur carcass, or if it was the Lucititan segment there, which is, valid as any interpretation. I remember Joshua Knupa from Germany, but he's the great paleoartist, does different, he did the Europasaurus book, and then also a whole variety of other paleo art, but he does a lot of like cool speculation and he had like some sort of giant titanosaur eating bones and stuff in one of his drawings. And I think that's a absolutely valid take on things, and it would be kind of difficult for something like a titanosaur to take in. I don't imagine they're really built to process them, at least in the mouth, where they can't really reduce them in size. They'd have to find a pretty small bone to be able to swallow whole, I think. But that could present an issue. I can imagine the choking hazard trying to swallow a whole rib bone, but maybe they could do it and then get the gastroliths to just crush it up in their gut.
I mean, that's a very. I would assume carnivores need to do that less than herbivores. Well, I guess they don't do it less. They just don't seek that out. It just happens to also happen while they're eating.
Yeah, exactly. They because of their diets, they don't need to look around for any additional, bones or anything. Osteophagy is the term.
And it's reminds me of I was talking to I'll never remember now. It just left my mind. But like it's like with here in the Hell Creek. Well, I say here in
Mhm.
America with the Hell Creek, it's like triceratops like feet are just very rare for some
Yeah,
reason.
not abundant at all. Yeah.
So so clearly those are like a target for the consumption because of like
Yeah, easier to process, or at
yeah.
least, you know, the skull. There's a better representation of Triceratops skulls, or more. There are more isolated skulls than there are like partial skeletons, if I'm correct. I think I am, but that's partially because of like the taphonomic reasons. The skeleton gets ripped apart and torn apart by T-Rex and everything, but the biggest and heaviest bone in the body is the skull on a triceratops, and it's that much harder to pick up, and there's not a ton of meat on it. So it'll probably get scavenged a bit, and then who knows, if a T-Rex is really hungry, it'll probably, crunch up the weaker parts of the skull, like the beak and the jaws. It'll probably crush up if it needs to. But either way, the skull is the hardest to transport. So the river sediments have a tougher time moving the skull compared to the rest of the bones, and then a T-Rex is not going to target it quite as much. Yeah, I think you may have heard of the idea that like T-Rex would rip off the skull to access like the neck muscles and everything.
I
And
think I've seen paleo art of that.
yeah, exactly. But it's pretty cool.
I think the whole like T-Rex could decapitate is a really cool idea, but it's like I don't
Did it need
maybe
to? Yeah.
does it
Not
need like is
necessary.
the
Well,
stomach not enough?
I don't remember the evidence for it exactly. I think maybe it was biomechanical where they were like thinking that, or it depends on the size of the triceratops too. If you get a big John out there, you're maybe not having the easiest time ripping the skull off. But if you have a smaller one, you can
Oh yeah,
probably do
for
that
sure.
if you're an adult Rex. But um, I can't remember if there was specific evidence they pointed to in terms of like the pattern of bite marks they would find on the frills, but I don't know if that was the case or not, or maybe
It's
what you'd expect.
could also have just been a good old case of somebody wanted to know if it could happen.
Yeah,
I love
exactly.
those studies where it's just like,
Myth
could this happen?
busted.
Nope, yeah,
Yeah. Mhm.
could.
Yeah.
It's I love our practice. It's literally just like I could do a whole paper tomorrow. I'm like, well, could a T-Rex bite this small little thing clean in half? Yes, yes,
Probably. It
yeah.
definitely could. Yeah.
Like, that is a horrifying thought that's just somebody's job.
Yeah. To think about horrible things all day.
it's it's somebody's job to figure out how hard dinosaurs could bite. Then
That's
it's
pretty
someone
cool though,
else's job
I think.
to
Yeah.
figure out what they could bite in half or just obliterate.
I'm interested. So, T-Rex is the one that gets all the attention in terms of that, but
Very much so.
there are other examples that you can test out, and there are examples like Allosaurus where they've talked about it like not having a bite force exceeding that of like a lion or something like that, which is interesting just because they're that many times the size of a living lion. But the way they're employing their bite is just like a tearing and ripping apart. And also,
Slash and rip or whatever it's
yeah,
called.
exactly. It was a successful predator. Just because it had a weaker bite than T-Rex doesn't make it any less of a efficient
Whatever it was
predator.
doing was working.
Exactly. It'll take on anything in the Morrison.
I think Torvosaurus had the more robust skull and took on that Tyrannosaur harder bite niche during the
Yeah,
draft.
its teeth are definitely more robust, or at least to my knowledge, I think they are. And then the skull itself, well, I don't know if we have any totally complete Torvosaur skulls. We definitely have some maxillae and some jaws and other pieces. And a lot of the time, I think, to my knowledge, the skulls are reconstructed and they're based on what we think megalosaur skulls look like. But we don't have we're missing like the nasal bones for I think most of the megalosaurs actually, and we don't have the best reconstructions of all of their skulls, but we have a decent understanding. And but I do love Torvosaurus. It's a really
Oh
interesting
yeah.
creature, rare. It makes you wonder what it was doing in the formation when compared to Allosaurus. And I think personally it was probably something that was a bit more solitary. Or when you think of Allosaurus, whether or not you believe it was an actual pack hunter or just a gang killer, which it probably was, a little bit of both. I don't know how coordinated it would have been, but it certainly seemed to have been numerous enough where maybe they're moving around in groups. Maybe like sibling groups move around together until they're mature enough to spread apart. But who knows? It's really just a speculation. But it would make sense to me that Torvosaurus is something that likes a bit more cover and is more of an ambush hunter. I don't think it was as lanky or like it was a bit more robust and heavier built than Allosaurus. So
Yeah.
be able to ambush sauropods and take them on by themselves, it would be an effective predator doing that, and having a bit more cover in like the forested areas and the mixed ecosystem of Morrison. But I don't know. I don't remember exactly how if the um, ecosystem or habitat structure has been studied like that, but I think there's been some work done on that. I don't know if that supports my belief or
I would
doesn't, but
actually be interested in a study on that, but also if the argument for allosaurs being pack hunters is or pack behavior is very limited. I
yeah,
would be very curious if it was somewhat like lions in Africa, where like, okay, well, this group focuses on this kind of prey while this group focuses on this kind of prey. So maybe like
yeah, exactly. Yeah,
an allosaurus that focused on like smaller prey was solitary. It didn't have a need to share its meals because there wasn't enough to go around with other allosaurs. But like a group that focuses on like maybe taking on sauropods, there were two or three so that they could actually coordinate to take down sauropods.
exactly. That's a really good point where you're thinking about individual or like population or subpopulation variation in their hunting strategies. It would make a lot of sense that not all Allosaurus are doing the same thing. You have localized populations that specialize in their respective prey. And I've thought about it before where, you have evidence. I believe there's evidence of Camarasaurus and that they were, moving in and out of the basins seasonally. And then um, I think the Diplodocids as well were doing the same thing. I don't know. I don't think there's really a ton of evidence for what the motion or like the movement of these migrations would have been or how extensive they would have been. But if you have different populations following the herds and some staying year round and trying to live off the scraps and stuff, you'd expect, the lower numbers there. But, it's all speculation, but it's definitely fun to think about. And I think I remember hearing some sort of thing about a potential gastrolith that was attributed to some sauropod. I don't remember what specifically it was or if it even is reliably a gastrolith. Because, you have to have like the direct evidence. You find the tumbled stones and you like to call them a gastrolith because they're in a formation where you have sauropods and other dinosaurs with them. But if you don't have them like right in the gut area, it's really hard to say. But
This is for sure a gastro. Yeah.
exactly. But I think I remember that discussion being that those gastroliths were sourced in an area like somewhere further in the Midwest, like Wisconsin or Minnesota or something like that. This is something from a while ago, but I remember it, and it makes me think like, how far are they going? Are they going this far for their migration patterns, and then they're ending up back in the Morrison Basin?
And I mean, that would also explain kind of Allosaurus, the taxonomical tree for Allosaurus is very, I guess it's in a hot topic right now because of Allosaurus anax / Saurophagnax, although that was
Yeah.
kind of a while ago.
Mm-hmm.
I mean, that could also explain why that even exists.
Yeah.
With it being larger to maybe prey on some of those sauropods.
I think so. It's also interesting thinking about the Morrison like chronology biochronostratigraphy. I don't know, however, biostratigraphically is the word I'm looking for, but um, chronologically speaking, the Morrison's about 10 or so million years. And I believe that the material attributed to Saurophaganax/Allosaurus anax is in the youngest part of the formation. And I had seen some mention that Torvosaurus might be missing from the uppermost part of the Morrison, which is interesting. You know, you have a small faunal turnover, but you have something that was living there and as a dominant predator for a long time being replaced potentially at the top of the food chain by the biggest species of Allosaurus, which, you know, that's speculation, or at least like maybe it takes more specimens and more study to prove one way or another. But you know, it could be the case that Allosaurus takes over as the dominant predator. And also, like, the extinction at the end of the Jurassic needs a little more understanding. I listened to Jim Kirkland talk about that, but it's really quite interesting because you know, you lose so much of the Morrison fauna in North America, and it makes you wonder what happened.
Stegosaurs vanish.
Yeah,
Going
exactly.
into the Cretaceous, sauropods start to heavily dwindle before pretty much vanishing everywhere except for like what Alamosaurus and like one or two others in like Texas.
Yeah, so you have the Alamosaurus. So in North America, you have sauropods from, well, you have the Jurassic, which is the, you know, the pinnacle of the sauropod diversity. But then you have a couple of different lineages living in North America through the early Cretaceous, and then by the middle of the Cretaceous, um, you have pretty much nothing. Or once the Western Interior Seaway becomes or reaches its maximum in like the middle of the Cretaceous, you really lose out on the sauropods, it seems like. And I don't know exactly what that relation is, whether maybe like the change of the ecosystem, the flora, and then maybe a change in like the migratory patterns or the nesting behaviors that
Yeah.
could be impacted, or we could be looking in the wrong direction for that. And maybe they're there the whole time. You know, who knows? They could just be like scrappy material. But you know, the idea, so back to the biogeographic aspect of it, that's a really compelling piece to me of how these dinosaurs, which are represented, you know, they're not represented in our best records in places like Dinosaur Park or Judith River or Hell Creek, but by the end of the Cretaceous, you get these titanosaurs back in the southern part of the United States. And whether they're coming up from South America, which I think is compelling, or they could be migrating in from Asia, because they never went extinct in Asia. They kept on strong. There's, you know, the Nemegtosaurus, and there's a bunch of other titanosaurs around in Asia from the late Cretaceous to the, you know, very end of it. But yeah, it's a cool thing to think about, you know.
I mean, I guess stegosaurs kind of get replaced by ankylosaurs
It
ish.
seems like it, yeah.
Not hadrosaurs, ceratopsians kind of. They
Yeah.
come in, but they just vanished. Like, they just whack. Like, oh,
Mm-hmm. Yeah, the gone entire, or as far as I'm aware, stegosaurs are gone in North America entirely in the early Cretaceous, but
yeah, they're just
they persist in Asia, and then there's I think in Africa as well. And then I think there's Amargastegos, so it lived alongside Amargasaurus and Bajadasaurus in South America. But there are examples from the southern hemisphere that they persist, and in Asia, but they persist for a while longer. But for whatever reason, they're gone in North America. Yeah.
I mean, I'm genuinely curious what. Yeah, okay, yeah, it's like what, 3 Wernosaur.
Yeah.
Dinosaurs in China, Mongolus, Stegus in Mongolia, and Pterranodon in South Africa.
Yeah.
So it's like, okay, yeah, you
A
can
huge reduction. Yeah.
count on one hand and not even use every finger.
Yeah, exactly.
It is kind of that loss of Stegosaurus. I am genuinely curious if they, well, I guess they wouldn't have survived because of the mass. I guess they were very specialist. They would have been very.
It must have been, so it probably had to do with like some sort of flora change, you know?
Yeah.
It must have been relying heavily on one type or a couple different types of plants, and then those plants die out in North America and maybe persist elsewhere in the world. But who really? I don't really know.
And I mean, I am curious if they somehow did survive longer, what their tree would have turned into.
Yeah,
I would love to see some spec evo kind of stuff of like, yeah,
bipedal,
these ones
bipedal
flourish
stegosaurs. Yeah.
again.
Hmm.
The early like Stegosaurus or whatever it is.
So there's
That,
Stegosaurus, which is the pachycephalosaur. There's Stegoros, which is the parankylosaur, so the southern
yeah,
hemisphere
that
ankylosaur. And then there's also, or the Stegosaurus, of course. But looking at stuff like the branching of the early armored dinosaurs is really interesting because you have, it makes sense like in the early Jurassic that it's taking place. You have the early stuff like Scutellosaurus, which is bipedal but covered in osteoderms, and then you eventually get to like Scelidosaurus, which is your classic, or looks like a classic ankylosaurian, where it's covered in osteoderms and maybe like probably quadrupedal, maybe facultatively bipedal. But and then by the middle Jurassic, get like real deal ankylosaurians and stegosaurs by that point. And where that branch really took place, is Scelidosaurus closer to the ankylosaurians? It would make sense based on its appearance, but
yeah.
where did the stegosaurs branch off there? And like the earliest, some of the more primitive ones are in Asia, and that's like the Wyangosauridae, which are the early ones that some of them have the spikes and stuff. But one that sticks out to me is Isaberisora, which is from Argentina. I think it's Middle Jurassic or so. And I don't think and that was one that I did on my project. I'm not going to grab it right now, but that one also had gut contents as well. And some of that was stuff like cycads in its guts, and maybe that indicates that stegosaurs have that reliance, or at least evolutionary history with the cycadoids and stuff like that. But because we don't have, I don't think we have the hind limbs, or at least like not the complete hind limb or forelimb of it, but its skull looks very stegosaur-like, and then the rest of its body is not exactly,
Yeah.
or it's like primitive comparatively. But I think it seems like
And
a good candidate for an early example.
stegosaurs are actually one of those. Is it one of, or is it just like the only where we really see gular osteoderms like that?
That's the only one I can think of. It would
Yeah,
make sense to be an ankylosaurid or a nodosaur, but
I
I
can
don't
see
know
in
if they
Canada's
exist. Yeah.
they're already super rare as is
Yeah, exactly.
because they just fall apart into like a million pieces, and then it's like
Yeah.
these little chunks that you have to put back together like in the worst jigsaw puzzle ever.
Yeah.
But I could see Ankylosaurus having something similar on
So
that.
they have it's really, there's a good picture online. I think it's David Evans who posted it, but it's from Zool, which is that beautiful ankylosaur from Judith River. But you have the osteoderms, which people recognize, the bigger armor plates and stuff, but you have the ossicles, which are like the chainmail essentially. So they're like smaller osteoderms all locked in
It's
together,
kinda
making in
like
yeah, exactly.
smaller. You have like the famous osteoderms, and you have like all the smaller. I mean, this is just like a recreation
Precisely.
from
Exactly.
so, but it gets the point across.
Yeah, it does. And it makes you wonder, like, are they located in the throat? But then you have specimens like Borealopelta where, it's so beautifully preserved. And I think Zool as well. I'm not sure exactly how well its throat area is preserved, but for Borealopelta, you'd expect you might see them if it's that well preserved. Yeah. So who knows? It probably might have just been absent, at least in nodosaurs, maybe.
I mean, it really is just very, very speculative for that.
Yeah.
I mean,
Yeah. So much salt. You need something to drink.
and I mean, especially with like it's the gastralia.
Yeah.
It's like you see that in a lot of stuff, but like sauropods, it's like missing. We're like,
Mhm.
you have a guy, he's like, yeah, I have one in my collection, but no one can look at it. And you're like, come on, dude.
Mm-hmm.
It's like that's actually one of the species where I'm like, it should have those.
It would make sense if they had them.
So much sense to have them.
Yeah. I don't know. A lot of the sauropods, you don't find a ton of articulation, or you do find some, but it's hard. The in the sauropods, when you have the bigger and bigger animals, it's that much harder to preserve it because you need that much more sediment to cover the animal itself.
On top of a sauropod goes down, that's literally every carnivore in the area is like,
Mhm.
that is
A
dinner.
buffet, dude. That would be a great feeling to be a carnivore stumbling upon a sauropod carcass.
Oh yeah. A full grown one goes down, you're just like that's literally just the dinner bell. Like
Mhm.
everything is coming in to rip it apart. So you need like fast quick events to just cover them if you
Yeah.
want articulation.
Yeah, and I think that exists at least for like Dreadnoughtus, which is like the best preserved, to my knowledge, like one of the best preserved giant titanosaurs out there. But even then, I think there are multiple individuals that were covered, and not all of them are complete. But because there are multiple in dying in that one event, maybe I think I could be wrong, but if there are multiple that die off in that one event, then you get enough to cover up that carcass and the multiple carcasses. But yeah.
The Mother's Day quarry has, I don't know if it's still in debate. I haven't kept up with it, and that
Mhm.
is my bad on that. It's
Yeah.
either more juvenile apatosaurus or like an a dwarf species of I'm pretty sure it's apatosaurus that got washed away in what they think is a flood. So you have like
Mhm.
a bunch of them that are just there.
Yeah. Yeah. So Dan did some work over there, and he was talking in our little talk at the brewery with the people. We were talking about the recent um, discovery, or at least the publication by Tess Gallagher, about the sauropod scales,
Scales, yeah.
and that was super awesome. That was like something I mean, you expect it to happen one day, maybe, ideally,
Yeah.
um, but in the circumstances, you expect the color preservation and the melanosome preservation to happen in these places like Lagerstadt, like Liaoning, or like the Yijian Formation or in Solnhofen Formation, where you have feather preservation or scales that are preserved with the body, or with like a complete body in these plates. But Morrison, you don't think of as preserving it like that, but you got it,
Morrison
and
is
she
surprisingly preserved.
she urged caution in the speculation, but like I love the idea of iridescent scales on a sauropod. That'd be pretty cool. Imagine like a big apatosaurus and it's displaying for the mating season, and then it just lifts its neck up and it has lights up the
That would, because I know there is that kind of, it's not quite the same thing with the Triceratops frill, where there's that
yeah.
theory that it might like rush blood up there to
Mhm.
like change the color of it. And of
Yeah.
course, Stegosaurus plates have that theory where they
Mhm.
rush blood up there for display or whatever.
Yeah. I like that idea. It's a really cool idea that they could change the colors of them, and I would want that to be the case. But at the same time, all the blood vessel grooves on both the stegosaur plates and the
Yeah.
and ceratopsian frills, all those blood vessel grooves can work to bring nutrients to the keratin that covers them. So, like, I was looking at a picture of a triceratops skull the other day, and just the direction and the arrangement of the blood vessel grooves, they're all like ending up at the exterior of it, where it gets bigger and bigger, and then those epoccipitals, which are like the little triangular points on the young ones, slowly fuse into it. And then I think, as far as I know, I think the stegosaur plates were covered in keratin. Yeah,
I
but I'm
don't
not
see
totally
that.
sure.
I
There
mean,
must,
there's no creature that just has like exposed bone. It's not
yeah,
like a real thing. So it's
yeah,
kind of
exactly.
good. It's probably, you can speculate that it was likely covered in something, whether it was just a thin layer of skin or keratin.
And that's the thing. So, like, is the triceratops frill covered in skin, or is it keratin? And I think the idea, or at least to my knowledge at the moment, that like the frill is covered more so in skin, and maybe like the exterior portions of the frill where you have the little epoccipitals are keratinized and stuff. But like the main plate itself, and where you might have like the eye spots and stuff, that I think would be skin. And then there was the interesting paper looking at like the fleshy structure on the hadrosaurs, but then also on those with the bony crests, and suggesting that maybe those are skin covered and not really keratin covered, and could extend that much more with soft tissue, like Lambeosaurus or Corythosaurus. It's pretty interesting.
And I mean, with the Stegosaurus plates, if they are keratin covered, does that mean they were bigger?
Yeah, exactly. And I like the idea, the speculative idea, like if they're keratin covered, like they're thorny, they're covered in like mini spikes and stuff.
Yeah, and I mean, that would also just add that extra level of protection.
Yeah, exactly.
Screw it, Spec Evo. It's like a Margosaurus. It's just a giant web.
Yeah.
It's got that idea. I mean, that's also really that, and like I think it's like Bajosaurus or Bajosaurus.
I I don't know if it's important, honestly. I don't know if I think it's all in the human realm of things. But I say Bajadasaurus, but at the same time, I don't know if like the Latin or Greek translation into that it accounts for like the Spanish JH sound, but who knows? I just say Bajada, like Baja Blast.
my general consensus of if people get what I'm saying, it works.
Exactly, yeah.
It works. Like it's like Diplodocus and like Diplodocus. It's like
or Giganotosaurus and Giganotosaurus.
Yeah.
Deinonychus and Deinonychus.
It really just like if people just understand what you're saying.
Yeah.
It kind of gets to that point.
And most of the time they don't.
And then we can sit here and argue for 10 hours. And
yeah. Paleo people will get it, but
figure out
everyone else, not quite.
Yeah, that's a new field we can open up, and like paleo pronunciation argument.
Yeah.
We can write papers on that.
All just the pedantic stuff. Yeah.
This is the Latin meaning for this, so it should actually be pronounced this way. Well,
I've had this.
Disagree.
Yeah, exactly. I've had this back and forth with people before, but like I say chasmosaurs, and like because it's the CH in Latin, that's like chi, or that's the letter itself in the Greek alphabet, not Latin. So it's the Greek alphabet, but chi, so like chasmosaurs, like the Triceratops lineage of ceratopsids. But then you have Campsosaurus and then Brachycampsa. That's what I say. Some people say Champsosaurus or Brachychampsa for the croc-like critter, and then the actual alligatoroid. But excuse me. Yeah. It's all
Chasmosaurus.
Yeah.
I'm not calling it Chasmosaurus.
I'm not calling it Chasmosaurus, goddamn it.
it's like the taxonomic naming where they're like, well, Saurophagonex had all this other sauropod species.
Saurophagus, or yeah.
Now we have to call the sauropod Saurophagonex. It's like, or hear me out, we don't do that. Because it's all arbitrary rules.
It is arbitrary stuff. And you think about it, like with modern species, you have animals within the same genus, and either different species or same species with different subspecies that can interbreed with one another. But then you have stuff that are in separate genera that can produce offspring, like cats and servals, for example. I don't think they're in the same. I don't think the serval is in the Felis genus. I think it's like Leptalurus or something like that. But these are human confines to our imagination, and you'd expect some of these animals to be able to interbreed and maybe even have viable offspring despite being in separate genera. But like a Tarbosaurus and T-Rex, for example, you totally expect them.
Or hybridization, not mutation.
Yeah.
So that does actually, I'm genuinely curious because we do have all those like different species of like tyrannosaurs on the western, up in like Alberta in that area.
Yeah.
How do we know there wasn't like some natural hybridization?
I would expect that to be the case in some point in history. We can't we just can't access the DNA, but we would totally expect, or I would expect, there's some kind of hybridization. A Torosaurus Triceratops hybrid, that would make sense occurring.
Upon the millions upon millions, literally hundreds of millions of years of dinosaur existence. No hybridization has happened.
but it's that much more difficult. It's just so impossible to prove, other than like we have the morphological, data available for dinosaurs, and then we would have to make the inference that it's a combination of these two creatures and not just a separate thing from the two
Just not a new
potential
species altogether.
parent species. Who
Yeah.
knows. But it's cool to think about.
It's like I love thinking about those, like it's kind of weird to say, but like the genetic,
Yeah.
like
Diversity
the
or
diversity, genetic,
intermingling.
genetic, like I don't want to call them problems because that sounds wrong,
Yeah.
but like the genetic malfunctions.
Yeah, I
Just
know what you mean. Like for a liger where it's, infertile, or a mule, for example, that
like
could totally be the case.
even simple stuff like albinism or melanism, like
Absolutely. Yeah.
those would 100% have been a thing
Yeah.
for sure. I mean,
Hmm. And even so, like you have the albinist or albinism and leucism, and then you have the melanism on the opposite end of the spectrum. But then you just have like living dinosaurs, which have a huge variety of colors. And like look at our like red-tailed hawks. I follow like some falconry accounts, and there's one example where this one red tail is just like bluish gray, it's like, or like nearly white colored. And it's not at all what you expect with your average red-tailed hawk. And then there are darker morphs, and then there are like, stuff with more red in them. But it's really pretty fascinating. And you can incorporate that into any variation you like. In your paleo art, you can do whatever you want
you
in
just like
terms of
based it
color.
on a bird.
Yeah.
Like I had this. It's just like a complete spec idea where it's like, what if Allosaurus was like based, like what if like the great horned owl, just toss that over an Allosaurus. Let's see what that looks like.
That would be an interesting combination. Yeah.
And it's just things like that where it's like small things. Like it's like, okay, well, this one has this slight adaptation to this bird. How do we know it doesn't have, like, we have all these different other species on top of just, we look at birds and crocs and things like that to kind of get those generic things because they're closely related. But it's also like, yeah, they're closely related, but they don't fill out every single niche in an ecosystem.
No, not quite. And that's the thing, you gotta. So we have the the living relatives, the dinosaurs and the bird, or which exists as the birds and their closest relatives outside that group and the crocs. But you have the huge, very broad swath of the ecosystem that you can only really use modern analogs with mammals representing similar niches.
So, like, what is it, like jaguars where they pull prey into trees to keep them from lions?
Leopards and then jaguars, I think,
Is that leopards that do that?
I like to imagine, yeah, I like to imagine like if Dakota Raptor, if it's valid, whatever you want to, whatever your thoughts are on Dakota Raptor and its, chimerism or whatnot. But, being able to drag its prey into trees will be pretty effective for living in an ecosystem with T-Rex,
Oh, they'd
keeping
have
in the
to
way.
climb fairly high.
Exactly. Yeah, exactly. And that's the thing. You need to balance out how high it can climb versus how high T-Rex can reach, and who knows. And then that was another thought I had about Balar. So the raptor like, whatever kind of paravian you think it might be. But whether it's more like a bird, maybe it was like, more like herbivorous. People think like it was like slow moving and herbivorous. Some people think it was more like a raptor or dromaeosaur. But I had the idea that like living in an ecosystem with Hatzegopteryx, maybe it could drag its prey further into a tree than a Hatzegopteryx could reach, with those double claws to be able to help in climbing like that.
Especially in the like Cretaceous period where it's like, yeah, there are very abundant forests. Forest 100% existed with these very abundant array of like trees and things like that. Is there a woodpecker kind of niche where it burrows into a tree or something? Like, is
Yeah,
that a
exactly.
genuine thing that exists?
Exactly. Like I think of so you have mammals that burrow in the ground and then also that nest in trees. And then you also have a whole variety of birds that nest in the trees. And there's, I don't know if there's anything or any evidence of like stuff that could hollow out a tree to allow for those burrows and nests to be made like we see in the modern day, but I at least imagine it so, you know?
I
Like you
mean,
don't have the woodpeckers and stuff, and you don't have, squirrels weren't around, but you have multi-tuberculates playing a similar role to rodents. And it looked like wouldn't you'd expect a microraptor to be nesting in a tree, and if it had a hollow to be able to nest in, then that much better for it.
and I mean, even like trees were like just a huge like root system goes out, and like parts of the ground under it are maybe hollowed out already.
Mm-hmm.
What lives there?
A Thesalosaurus. Yeah.
Yeah, I mean,
Mm-hmm.
those get other. I mean,
Leptoceratops, probably. Yeah.
it's like an already it's a pre-built house. I'm sure
Yeah.
something would inhabit it. And I mean, you think about that like all the way back to like to the beginning of.
You're sort of frozen on me. I'm not sure if I am on your end. Maybe it'll come back in a sec. I think I got you.
Technical buffer there, but I mean, even those like very early tree. I mean, the first trees are kind of just tubes, so I mean,
Yeah.
you're not getting much there.
Archaeopteryx. Not to be confused with Archaeopteryx. Yeah.
Gotta love the naming. It's
Naming
just,
conventions for the win.
let's
Mhm.
change one letter. It's a completely different thing now.
It's a tree and not a primitive bird relative.
What if you didn't do that?
Mhm.
What if we didn't do that, guys?
I wonder which came first. Actually, that's a good question. Which was named first, Archaeopteryx or Archaeopteryx? You know.
I
Who knows? But yeah, like going back to the Devonian, you even have those primitive trees. Yeah.
not to mention like you get like deers and things like that where you'll see that they like sharpen their antlers on trees.
Mm-hmm.
Did Stegosaurus sharpen its Stagomyser somehow? That's probably
Yeah, would like you see big cats today, clawing on trees. Would an Allosaurus do the same thing, or a Megaraptoran?
I mean, especially something like Triceratops. Would it have with those horns definitely being put to use
Mm-hmm.
within at least interspecies collaboration or that's collaboration. That's putting it lightly.
Yeah, that's a nice way of putting it.
They killed each other.
Mm-hmm.
Rah! Like,
Mhm.
especially Triceratops with how surprisingly solitary it was.
Yeah,
I mean,
exactly. You have it makes you question like, or yeah, but the trees are one thing, but like the herd dynamics of different ceratopsian species. You have huge bone beds for Centrosaurus and Pachyrhinosaurus, and then I believe there are at least decent sized bone. And Ionosaurus is another one you have big bone beds for with a curved horn. But
the
I think there are
I think.
multi-individual bone beds, or at least decent sized herds of maybe Styracosaurus. I can't remember exactly, but
It's centrosaurians that tend to be very. They
yeah,
tend to have the very large herds.
exactly. And it makes you wonder, A, just how big it was, and are those bone beds representing one event, or is it like a continuous every few years, or
Migrate
every
the
year
same
there
amount.
migration and stuff dies, or is it every year or every few years there's the migration and then a bunch of stuff dies? I don't really know. I'm not super familiar with I'm forgetting the name of the bone bed for the Centrosaurs in Alberta, but but you have that huge amounts of those, but it does seem like there's not quite as many bone beds, or like maybe not nearly the same
They tend to be
degree.
one-offs.
I think there are examples of bone beds with like multiple individuals of Triceratops.
I think the
They're like
largest we found
3 to
was like
5 or so. Yeah, not a lot.
5-ish.
Yeah.
Which I mean, like, is that a bone bed, or is that like one breeding event and then like a flood came and killed them all? Like,
Yeah. Is it representative, and like are any of these representative of how they actually, live their lives and in their herds?
yeah. No, the Triceratops were just so successful that there'd be one off picked off, and the herd would just leave.
Mm-hmm.
They went east.
Yeah. See ya.
Never be discovered.
Mm-hmm.
It's even like ankylosaurs, where it's like, okay, we have them in the like ankylosaurs. We have it like early Jurassic, late Jurassic, no middle Jurassic,
Mm-hmm.
or
We
not
got
Jurassic.
Spicomelus, which is Middle Jurassic in Morocco. You get the wild experimentation in ankylosaurs, which I think is pretty fascinating. Well, you got the, I think there's another early one there. They're the early ones in like the early Jurassic, like Scelidosaurus, and then I think there's one that was of a similar like phylogenetic grade that was found in China from a similar age. But yeah, then you get to like it's more definitely more sparse. Like globally speaking, Middle Jurassic rocks aren't really well known by comparison to early or late Jurassic beds, but you do have Spicomelus, which is a cool example of like the experimentation there, because it's really just a completely novel thing that never appeared again, where you have the spiked ribs that never shows up again in any ankylosaurs. They all just have the osteoderms, which exist off of the bone or off the main skeleton. But yeah.
Oddly enough, I guess the closest thing wouldn't really be ankylosaurs with the osteoderms. It probably would have been stegosaurs with the actual like spikes.
Maybe. I think, well, the thing is, I think the spikes and the plates on stegosaurs are modified osteoderms.
Oh yeah, for sure. I mean,
Yeah. But even then, like, but do you consider the spikes emanating from the ribs in Spicomelus? Are you considering those osteoderms, or are those just like bony growths that resembled later osteoderms in other creatures? I don't know. It's really interesting though.
I like to think that later on the ankylosaurs would have had their own tree that kind of convergently evolved, possibly back into something stegosaurian like.
If they survive the extinction event, I hope they would. Yeah, I hope they would have like a Glyptodont clone, or like Dinosaurs with the spiky tail club. There should have totally been an ankylosaur with a spiked tail.
Just giant land turtle.
Mm-hmm.
I mean, I really think there really could have been two different. I mean, stegosaurs vanished when ankylosaurs were really thriving in the Cretaceous, but like assuming the KT extinction doesn't happen, the whole argument that the Cretaceous fauna were dwindling is kind of becoming more and more untrue.
Yeah.
I mean, Nanotyrannus helps with that. All these ankylosaurs help with that.
There's, like at least three species of Caenignathed oviraptorosaurs in the Hell Creek. And who knows, I think there's definitely more than one ornithomimosaur in the Hell Creek. Maybe, who knows how many. The represented, or like the diversity of smaller, mid-sized to smaller theropods is just like really poorly known, really scrappy, and it's probably very undersold. Like we have a Caroraptor, which we have from, the Dennery, and a maxilla with sort of distinctive teeth. But then there's, Dakota raptor as well. And then, but who knows, there are probably a couple other species of dromaeosaur in the Hell Creek. And I think there's, a Microraptorian in the Hell Creek as well, because
probably
I'm pretty sure there is. They're like isolated claws that are often or sometimes attributed to them. And then you have Hesperonychus, which is pretty fragmentary from Dinosaur Park. But if you have that, then that boosts the idea that those were living in those forests as well.
I mean, who would have known whenever it came to ankylosaurs if there was a need for, it sticks with a defense, but then there is actually a need for, maybe there's quicker predators that the defense can't quite do whatever, that it actually just needs straight up offense, and it just gets spikier and spikier until we basically have stegosaurs again. I mean, it really is. The KT extinction really cut that off for us.
And it does, why would it do that? But
I have to do that.
Yeah, exactly. But that's a good point and good thing or interesting thing to consider, because you have the evidence for intraspecific combat in ankylosaurs with the Zool, where you have like they're clubbing each other on the sides of their body, and they'll have those patterns of damage there. But is the same thing occurring in stegosaurs, or are they using that exclusively as like predator deterrence, because they, as a non-lethal means of combat?
They didn't really have that.
Exactly.
So I mean,
plus they wrestled around.
I guess they could have possibly somehow like shoulder to shoulder. something.
Yeah, who
Or
knows?
even the sauropod thing where they stand up and just hit each other.
I really love that. So like, the prehistoric planet was what a treat, you know? What a treat. Nice time to be alive that we can witness
Very
prehistoric
much
planet
so.
in all of its glory. But I really love the speculation that they did because it seems very realistic. Or in the Dreadnoughtus fight I'm talking about, where you really feel the mass of the creatures because they incorporate like it's not just like giant kaiju's fighting. It's
Yeah.
yeah, yeah, but it reminds me a lot of like elephant seals. They did a really good job of making it feel like these two massive things are just bashing. It's like it's not just like giraffe neck swinging, which is a specialized function where they have those ossicones and they bash each other with them. And but you can't do the same thing with a sauropod. It's not really there, or at least to my understanding, their skulls and necks aren't really meant to be able to swing and to hit
No,
each other like that.
it doesn't seem like that.
But it makes more sense to be able to like neck wrestling and just using your weight slamming into one another, not headwise. That would just probably just kill them. But doing that and then wrestling and spiking each other with the thumbs if they have those, like, not, I can't remember who said it or if it's the case. I don't know if they're, I don't even know if the thumb spikes are even preserved, or the thumb spurs, however you want to phrase it, are preserved on Dreadnoughtus, or if they exist. um that might have been like a Skeleton Crew review video that they mentioned that on. I don't know if you guys or if you listen to them, but they have a lot of interesting takes. And
That might have been, yeah, I think that's, I wouldn't be surprised if they had that.
yeah, a lot of sauropods
Common sauropod thing.
did, but in some of the titanosaurs, at least like later on in the Cretaceous, some of them were like really reducing their
Oh yeah.
feet, where they were just like nubs at the end. They some like didn't have the claws and the forelimbs, I think, but I could be off, but I think I'm right. But either way, I don't like. Regardless, you have two massive animals, and they represent it really well, using modern analogs to the best of our knowledge. And I think that was
Especially
really
with
great thing.
stegosaurs, which is weird, is that their forelimbs are so tiny.
They
And
are,
it's a very common thing, but like
yeah.
they seem really reduced for that, where it's like they're like
They,
that.
yeah, their hind limbs are way longer, but you know, that would make, if stegosaurs are competing somehow, it would make sense if the males are like rearing up on their hind limbs and wrestling with one another that way in a non-lethal kind of way. You know?
I could very much see that, or maybe it was lethal. Maybe they
Yeah,
had.
maybe they're just stabbing each other. Maybe that's why they have the Gular armor, so that they don't get like a lethal throat shot on each other when they're fighting.
Yeah, that could be. And I mean, even for those, some of those like later stegosaurs where they have those like shoulder plates and things, or like the shoulder spikes, I could see some kind of like jousting kind of thing.
I think
going on
actually,
that.
I think it's more so in the more primitive stegosaurs that you have this shoulder spikes, and like Stegosaurus
There's
itself, you don't have that, and then I don't think you have that in Urosaurus and some of the others. I don't. Most of the stegosaurs aren't really well preserved or like known from extensive remains. So who knows? Maybe it showed back up, but Stegosaurus itself being like the model for the more advanced varieties, I don't think they have those ones. But you know, either way, like the ones that did have Gigant Spinosaurus, classic dinosaur name, but that one could have totally used its gigant spines to joust with one another.
I like looking at a stegosaurus skeleton. I could see it having the possibility of rearing up.
The possibility of what?
Like rearing up.
Oh yeah, absolutely.
Totally see that happening.
Mm-hmm.
I would actually genuinely be interested if there's a study on that somewhere, if they could or couldn't.
I don't know. I don't know if there's a study. Maybe there is. I don't know off the top of my head, but there's definitely been plenty of paleo art where they're depicted, and there's like even museum mounts. I think it may be I can't remember which one, if it's a prehistoric museum or the Morrison Museum, somewhere in either Utah or Colorado, where they have a stegosaur standing up on its hind limbs.
Well, I found a picture of one, but of course it's from a website called 9gag. I have no idea what that is.
Don't want to know.
I don't want to know, don't care. And of
Mhm.
course, you don't list the museum.
Of course not, but yeah.
Gotta love that. Gotta
Mhm.
love it. But
I know it's one of those. I know it might be Morrison or maybe Prehistoric Museum, but yeah, either one of them.
ScienceDirect.com tends to be a good website. Current biology, Stegosaurus. Oh, this is just an entire bunch of papers on Stegosaurus. Okay. It'll be in there somewhere.
Yeah. But
Maybe
yeah,
I'll do it.
biomechanically speaking, it would make sense that they would be able to do that.
Especially since they have that like overly seemingly reduced forelimbs.
Yeah.
And of course, there's probably of course the argument for the tail being able to get that better, and there's probably better like pivoting with the back legs and the front legs.
And it probably would have been helpful for stegosaurs to be able to reach up and have that sort of mixing with or like what's the word? Intersecting. Yeah, being able to intersect with like the feeding profile of sauropods where they could have a greater reach than some of the other smaller critters around them. And if in the Morrison there's limited amount of plants growing in the ground when it's the
Pretty much
dry
so.
season. What's that?
Especially like later Morrison where it is getting more droughty.
Yeah.
That especially that could be why Stegosaurus specifically seems to be the one embodying that more than any other stegosaur.
Well, then you have Miragaia, which if it has similar proportions to, Stegosaurus, where it has those much longer back legs, it has an even longer neck proportionally and
Yeah.
can act like a little sauropod in its own right with plates and spikes.
Of course, it probably did a lot more lower browsing because that was probably heavily more available.
Yeah.
Because sauropods would have, they 100% take the niche for everything higher up. I mean, that's why macronaria necks are like that. So, I mean, did they complete with maybe diplodocus where their necks are more this way, or they just lawnmower everything? Or I would.
Who knows? It's really hard to say, because maybe like there might be the evidence of like cycads being an important staple in stegosaur diets, and then diplodocus, while probably hoovering up whatever they could, honestly, but like with their teeth, their pencil-like teeth suggest they're eating softer vegetation and like picking it up, and their posture, while maybe not horizontal like in Walking with Dinosaurs, it wasn't quite as raised as a macronarian like Brachiosaurus or Camarasaurus. And yeah, so they're potentially lower to the ground food sources like ferns and horsetails and whatnot. So, but they probably intersected to some degree with stegosaurs, but maybe they specialized a little bit more in certain types of flora.
And it does. Stegosaurus seem to have that long-ish neck.
Pretty long, yeah.
Fairly. Stegosaurs are just in general are so weirdly proportioned.
Definitely, yeah. They're strange critters. Have you ever seen the picture in like the old newspaper where it's like the most grotesque animal of all time, or where it's this like 1920s newspaper, or maybe even earlier than that, where like the most devious, grotesque of beasts of all time, Stegosaurus.
The Stegosaurus. Yeah, that
it was like there's no reason to be hurtful.
Proportioned animal. I feel like they were very, very specialist.
Yeah,
they must have been fitting some really weird niche, like generally, just they have such weird proportions that it's like, okay, so like it's got these weirdly reduced forelimbs, this long neck, it's got this crazy thagomizer, it has these plates. It's got like gular osteoderms.
There's so many aspects of it that we have like a very limited understanding of how it really functioned. We have our speculation and stuff, but it's really specialized. It's functionally sort of a unique creature. It's really
And
quite amazing.
their section of the tree is easily, other than maybe Pachycephalosaurs, like the smallest.
Yeah, they're definitely,
I think it might be
you know,
smaller now.
yeah. Well, we have the Pachycephalosaur, or these are two lineages. They're iconic and stuff, but they don't really last super long, or they're definitely really long. I will say that like Stegosaur evolution from the Middle Jurassic, maybe who knows how far into the early Jurassic they go with the diversification of the thyreophorans and stuff, but Middle Jurassic to really reduced numbers, but by the Middle Cretaceous, like I think Albion or Aptian in Asia, you have some of the last Stegosaurs. Um, but and then with similarly Pachycephalosaurs, you don't have really great record of because
They appear
both are
very late in
rare.
the Jurassic, don't they? Like
Well, I don't know if we have
Cretaceous.
any. So yeah, well, we don't have any record of Pachycephalosaurs in the Jurassic, but the earliest relatives of them, or where they would have been really similar to the early ancestors of ceratopsians, we have the evidence of the early ceratopsians like Yinlong and stuff in the Jurassic, but then it was only recently that we have any understanding of what Pachycephalosaurs were like in the early Cretaceous with Zavacephaly, which was that one I published in September, like 110 or so million years ago. And that pushes their record back, and it's like one of the most complete Pachycephalosaurs. And at the same time, despite being like the oldest representative of it or of the group, at least known from good remains, it's still a very advanced looking Pachycephalosaur with like a complete dome already.
Oh yeah, it's when did that live? When did it live?
110 or so, I think.
When did you live? Not when did it die? When did it live? 108 to 115 million years ago. So yeah, early Cretaceous. They literally, they're just Cretaceous. They're
they just pop up, you know. So that means you got to go to earlier formations than that, where you might emphasis on the might find evidence of earlier, more primitive versions of them, but
I could see very, very late Jurassic at best.
Yeah, they could be there.
Very like butt in last couple thousand years.
No pun intended.
Yeah, no pun fully intended. Pun was fully intended. But like, what about like micro Pachycephalosaurus?
I can't remember if that is an actual Pachycephalosaur or if it's like a basal ceratopsian that was thought to be a Pachycephalosaur. I don't remember where it fits in, but I think it's a little bit later than Zavacephaly.
83.6 to 72.1 million years ago.
Yeah.
I think it's tiny. I think
it is.
It looks kind of like a, well, I don't, it's got a weird dome on its noggin. I'll tell
it
you
does.
That much.
Well, that might be how it's, I don't know what the actual fossils look like off the top of my head, but that's how it's been reconstructed for sure. Yeah. I don't know.
I think somebody got something wrong here.
Yeah.
So somebody missed a lecture.
Yeah, I think so, or maybe a couple.
More than that, I don't think they showed up to the class at all.
Is that the holotype where it's just the hip bone?
I have no idea.
I don't know.
Ilium, is that the holotype? Is that it? Is that all we have?
Hopefully it's more than that. I would really hope it's more than that. But maybe not. Maybe not.
At this point, I'm not putting anything past. I mean, we describing species based on footprint at this point. Wow, I promise I can spell. Okay, yeah.
That's the Mei Long.
No, yeah, that's.
Go to the skeletal, okay. So you have that, then you have a little bit of the jaw. So no dome. I think the dome was all speculative.
Huh. Is it micro? Yeah, that's micro Pachycephalosaurus, all right.
That's the regular. That's that macro Pachycephalosaurus.
The macro. If we just, that's actually a pretty good name for for
Yeah, you
Pachycephalosaurus.
just got to find something bigger than Pachycephalosaurus, and you can name it that.
Nah, you can just name anything.
Yeah, exactly. You can.
It tends to be how we are.
Mhm.
I mean, especially with Pachycephalosaurus, they're just extremely rare as is.
Yeah, even in places where they're like thought to be well known, like Hell Creek or maybe like Dinosaur Park or something like that, it's just, I mean, this is the case for most small bodied dinosaurs in the first place, but there's that major deposition or like preservation bias for them because they have that really dense and durable dome. But yeah,
And
the
that
rest of the body is not so much, not so well preserved.
that actually
Zebus I think is the most complete one.
probably that wouldn't
Yeah,
surprise me.
yeah,
That also makes me think: is there a possibility for like, what about like mountainous species?
exactly.
Could
There's
they have been more mountainous, maybe filling in some kind of like mountain goat niche?
there's been that suggestion or that theory about that habit, but at the same time, and that could certainly be the case. I think they could certainly have lived in the mountains. There are, I think, the Two Medicine Formation where Myosaur is from. I think there's Brontotholus, which was the one that was recently named the Thunderdome. That's pretty cool, but that would have been somewhat mountainous, but uh,
Thunderdome.
very near the Rockies and everything, the early Rockies forming. But at the same time, I'm pretty sure, I feel like the stuff in the Hell Creek, like Pachycephalosaurus and then Stygimoloch, depending on your perspective on that, I think it's its own, reasonably speaking, it might be its own thing. And Stegosaurus on its own, that's not Hell Creek, but it's Dinosaur Park and other Campanian formations. But those are more coastal. And I think despite their rarity, I think they were probably native to those areas. So I think they spanned a pretty wide variety of habitats. But it's all speculative with
It's
how scarce those materials are.
it actually is that the one science where the answer 90% of the time is I don't know.
Exactly, yeah.
Is because it's like you find like a pachycephalosaurid anything. It's like, okay, yeah, this is you got a pretty decent chance that it's like going to uncover some new stuff.
Yeah. Yeah. Anything like that's the thing. If you find the dome, that's how you know what you got. But like if you have other material, it's really hard to find stuff to reference between that, and it's hard to make any solid judgment calls. Like it could also be something similar like a Thesalosaurus. There's a lot of overlap. I don't know because Pachycephalosaurus isn't super well known in skeletal material. So people will say like, oh, this vertebra here or this claw here is probably Pachycephalosaurus, but there is overlap or at least similarities to Thesalosaurus and in the same environment, which is probably more common, I think. I'm not totally sure though.
They could just find the rest of the dinosaur. That would solve the problem.
That would that would solve, yeah,
That would solve so many problems.
yeah.
I wish that was the case. You could just do that.
Me too. I think a lot of those formations in Mongolia and China, you have those beautifully complete specimens, and you have a variety of different geological or taphonomical components there, but a lot of the time in the eastern, or not eastern, I'm saying east of the Rockies in those river systems that drained, because they are in those river systems with those currents, they move the skeletons around that much more, and there's that much more disarticulation. So it's that much harder to find complete specimens with those materials.
I mean, this is just like for lack of better terms, the megafauna of the time. I mean,
Yeah. It's a huge
think about,
bias toward it. Yeah.
think about all the millions of small species that we just will never ever know about.
Yeah.
Insects,
Yeah.
small rodents, and things like that. I mean, those microsites really help with all of that.
Yeah.
I mean, they're very important.
Hugely. But at the same time, the microsites are they they represent that cross section of the ecosystem where you find a huge swath of what actually existed there, but at the same time that material is all disarticulated. It's all isolated teeth and small bones and stuff like that. So while you get an idea of what is there, you really wish that you had like even the partial skeleton of something that you find that might be rare in a microsite, like just to have a better understanding of what it was. But yeah, either way. So I got to wrap up soon. I got to head out to work shortly, but this has been an awesome discussion. I'm very
Yeah,
glad I came on and wanted to talk to you. So
I'm
thank you
so
for
glad I
having me.
could get you on, man. And if I'm not mistaken, for all of you listening, he is got my fingers going different directions. Actually, I can just do this. I just realized I can just. I have you as a speaker for Prehistoric Live. I don't know if he was on there when I did the episode last week. Time's weird, guys. Time is weird. But if you want to hear him talk about some other stuff, he will be a speaker one of the days. Have to figure all that out further on down the road. But
Mhm.
I do
Yeah,
have
I'm on
right.
Instagram at Paleo Noel, and Paleo Noel is my YouTube as well. I should really post more long form content on there. That's my goal in the long term. And then also, I'm on TikTok and I post a lot of this stuff there. And yeah, my TikTok is Noel the one and only, but otherwise Paleo Noel on my other platforms. And I'm on Facebook as well. And yeah, just like
So I
I'm
guess
always ready. I'm always happy to talk paleo with other people. So you can just hit me up if you want.
and if you ever want to come back on and talk about something, you just shoot me a message, man.
Gladly. Thank you.
And I guess before we wrap everything up, is there any final thoughts, words of wisdom, inspiring speeches you'd like to give to whoever's watching this?
Absolutely. The world out there, the world of paleontology and dinosaurs is huge, and we are only scratching the surface of it. There is so much left to find. We think we found so much, but there's just millions and millions of acres in our planet that preserves rocks and fossils of the right age to be able to find new dinosaurs and have better understandings of ones we've found previously. Um, Humans will go extinct before we find every dinosaur species. So have that little thing in the back of your mind just to know that it's a bittersweet kind of feeling, but it's reassuring that you're not going to be in the generation where dinosaurs have all been found. That's not going to happen ever. So yeah, just remember that.
Yeah, that'll happen when we invent time travel.
Yeah, which hopefully, man, I don't think that's going to happen, unfortunately.
Also,
I don't
records are
know.
about to get real weird then.
Oh yeah, they're gonna find my boot, my
This
boot
T-Rex
print.
is wearing clothes.
Yeah.
What?
Well, these dinosaurs are wearing Timberland boots in the early Jurassic. What the
You got the
hell?
Tims on.
Hmm.
Sauropod Tims.
Hell yeah. Size 50.
Higher. Higher.
Yeah, exactly. All right, man. Thank you so much for having me on.
Thank you so much for coming on, man. It's always an honor to be able to talk to other people in the field.
Always. It's always a pleasure. Like you don't really have much of an opportunity to do that in like the real world, but like, being
It's
able to
much
just sit down and just yap about dinosaurs for an hour and 57 minutes is a great thing.
like I said off screen. Internet technology, it's a blessing and a curse. It allows us to do things like that, but it malfunctions every other hour.
Certainly. All right. Take it easy and have a
You gotta
great
go.
rest
I'll
of
let
your
you
day.
go. I'll see you around,
See
man.
you.
All right. Well, that was Paleo No. I will link his Instagram and his YouTube once I find that. Comment section down below. Go support him. But that is all from me for right now. I'm your host, Eric Crawford. This has been Prehistoric Live Podcast. Remember, get your tickets for Prehistoric Live May 1st, May 2nd. But that is all from me for right now. I hope you have a great afternoon, morning, evening, or night. Remember, keep it prehistoric. Goodbye. Huge shout out to today's sponsor, Dinosaur Trips. If you enjoy these majestic creatures I talk about here on the podcast and would like to go see them for yourself, I would heavily recommend Dinosaur Trips. Dinosaur Trips is a company created to give people a behind-the-scenes in-look on museums and dig sites, along with just having an amazing time looking at these amazing, fabulous, majestic creatures. So If you sound interested, go to www.dinosaurtrips.com and tell them Prehistoric Life sent you and get $250 off your tickets. Now, back to the show. If you follow my account, you probably like dinosaurs, fossils, and the prehistoric world. And if you have ever shopped for fossils, you'll see that a lot of them have some very high prices, rightfully so, because they are usually one-of-a-type specimen. Then you go look for casts, and you see a lot of these low-quality casts going around, so you just don't know what to do. You either have to buy something super expensive or something super low quality. Enter dinosaur skeletons. Dinosaur skeletons specializes in creating museum-quality replicas of prehistoric life and is renowned for its highly detailed reconstructions. Founded by a professional paleoartist with over a decade of experience in the collectibles industry, they are dedicated to providing enthusiasts, collectors, and institutions with the opportunity to own magnificent, lifelike prehistoric replicas. Each creation is crafted with exceptional care and attention to detail. This means they are highly accurate to their source material, super high quality, and museum grade level quality. This is probably the closest you could get to bringing home a museum exhibit. They're also fairly affordable for the accuracy and quality put into it, which also means they make great gifts for birthdays and holidays for that collector or dinosaur enthusiast you know. So go check out Dinosaur Skeletons and get your cast today.